Part 18, let's go. Constant of Proportionality.
Okay. We're asked, what is the constant of proportionality between y and x in the graph?
Okay.
And just as a reminder, we're asked, what is the constant of proportionality between y and x in the graph? And just as a reminder, when we're talking about constant of proportionality, it sounds like a very fancy thing, but it's not too bad. If we're thinking about any xy pair on this line, let's say right over here, we have some x comma y. If y is proportionate or is proportional to x, then that means we can say that y is equal to some constant. Y is equal to some constant times x. And that constant, that is our constant of proportionality, right over there. Sometimes you will see this expressed if you divide both sides by x. Sometimes you will see this as y over x is equal to the constant of proportionality. It shows if you, for any xy pair, if you take your y divided by x, what do you get? That's the same thing. So with that out of the way, see if you can answer their question. What is the constant of proportionality between y and x in the graph? Well, they very clearly give us a point right over here. This point is the point
2 over 3,
comma 2. And so we could set it up a few ways. We could say, look, when y is equal to 2, x is equal to 3, and so 2 would need to be equal to some constant of proportionality times 3. And if you wanted to solve for this, you just divide both sides by 3. So divide both sides by 3, and you would get that your constant of proportionality is 2/3. Another way to do it, right over here, well, here we've kind of already solved for a constant of proportionality. When y, or we can say when x is 3, y is equal to 2. In either case, our constant of proportionality is 2/3. Let's do another example. So here we have...
What is 2 divided by 3 though? Okay.
Which line has a constant of proportionality between y and x of 5 over 4? So pause the video and see if you can figure that out. So the key realization is we should test...
Which line is a constant between y x of 5 over 4? Okay, so would that be the same as our y equals 5? And then x equals 4. A.
Test points on these lines.
Line A.
We should test xy pairs and say, well, look, if you take our y...
No, not really. Y of 5 and x of 4 actually B. Oh my god, I'm an idiot.
Do we get 5
line
fourths?
B?
Because that would be our constant of proportionality. So let's first try, try line A right over here. So line A, let me find a point that sits on it. So that looks like a point that sits on it. And so if I take, this is the point 2 comma 5. And so if I took y divided by x, I would get a constant of proportionality as 5 halves. So A is not going to be our answer. We want to get to a constant of proportionality of 5 fourths. All right, let's try B. Okay, B, let me find a point on B. Looks like this is a point on B. That is the point 4 comma 5. 4 comma 5. And so in this situation, K would be our y, which is 5, divided by our x, which is 4. So it looks like B is our choice. For kicks, you could also look at the constant of proportionality.
For kicks.
Now there is one interesting example that I just want to touch on before we finish these examples. What about a situation where y is equal to x? What is the constant of proportionality then? And what would it look like as a line? Pause this video and think about it.
Oh, let's think about it. Wait, isn't it the same shit or earlier? Like, the K would be here, right? So, what the fuck?
Well,
I think it's gonna be like just a straight line. I don't know.
There's really nothing.
I mean, it would just horizontal or vertical, right?
New here. It's just you might not
know
really
kind
see
of
the constant of proportionality when you see it expressed this way. But y is equal to x is the same thing as y is equal to 1 times x. And so then it might jump out at you that the constant of proportionality is 1 in this scenario right over here. Or if you took y divided by x, y over black color. Or if you took y over x, you divide both sides by x, you would be left with the constant of proportionality, which would be equal to 1. And if you wanted to graph it, well, it would just look like this. Y would be equal to x for all x's.
Constant of proportionality.
When your constant of proportionality is 1, those would represent points on this orange line that I just constructed.
Okay, cool. How many okay, 4 more videos. This is strange looking.
We are asked, what is the constant of proportionality in the equation 4y is equal to 8x? Pause this video and have a go at this question. Alright, so we might be used to seeing constants of proportionality when we have equations in a slightly different form. A constant of proportionality
I'll be right back. Came back. Okay, cool. Record. Was I able to post it earlier? Okay, that actually worked.
Is what do you multiply x by to get to y? So y would be equal to our constant of proportionality times x. But this isn't written in that form. So what we do is manipulate it a little bit so that we can see it in that form. And the obvious thing is we just need to solve for y. So right now it says 4y is equal to 8x. Well, if we want to solve for y, we can just divide both sides by 4. And we are left with y is equal to 8 divided by 4, which is 2 times x. Well, now the constant of proportionality jumps out at us. To get y, we have to multiply x by 2. That is our constant of proportionality. Let's do another example. Here, we're asked, which equation has a constant of proportionality equal to 1/2? Again, pause the video, try to enter it yourself. Okay, so I'm just going to go equation by equation.
By 1/2. I think that would be 3.
And calculate their constant of proportionality and see which one has a constant of proportionality equal to 1/2. So this one right over here, choice A, clearly has a constant of proportionality of 1/8, so we can just rule that out. Equation B right over here clearly has a constant of proportionality of 4, not 1/2, so we could rule that one out. Let's see, the constant of proportionality for equation C, if we want to solve for y, we can divide both sides by 6. And so we're going to get y is equal to 3/6 times x. Well, 3/6 is the same thing as 1/2 times x. And so there you have it. We have a constant of proportionality of 1/2. That's the choice I like. And we can verify that this one doesn't work. If you want to solve for y, you divide both sides by 3. And you get y is equal to 9 divided by 3 is 3x. So here our constant of proportionality is 3. So we can feel good about choice C. We're told the quantities x and y are proportional. And then they give us a table where they give us a bunch of x's, and then they give us the corresponding y's. When x is 4, y is 10. When x is 5, y is 12.5, and so on and so forth. Find the constant of proportionality r in the equation y is equal to r times x. So pause this video and see if you can figure that out. Alright, so we want to find the constant of proportionality. I sometimes have trouble saying that. R, where for any x, if I multiply it by r, I get y. Well, we just have to look at each of these x's and figure out, well, what are we multiplying by to get to y? So what do I have to multiply 4 by to get to 10? Well, if you multiply it by 10 fourths, then you're going to get to 10. And 10 fourths is the same thing as multiplying it by, let's see, that is 2.5. So this is times 2.5. So let's see, does that hold? In every case, if I multiply by 2.5, if I multiply x by 2.5, do I get y? So 5 times 2.5, 5 times 2 is 10, and then another half is 2.5. It indeed does equal 12.5. 5 times 2.5. And then here, 10 times 2.5 is clearly 25. And you can work it out by hand. I did a little bit of the multiplication in my head. But you can see in every case, I take my x, I multiply it by 2.5, I get my y. So in every case, I take my x, multiply it by the constant of proportionality 2.5, I get my y. So what's the constant of proportionality? It is 2.5. We're told that cars A, B, and C are traveling at constant speeds. And they say select the car that travels the fastest. And we have these three scenarios here. So I encourage you to pause this video and try to figure out which of these three cars is traveling the fastest. Car A, car B, or car C. All right, now let's work through this together. So car A, they clearly just give its speed. It's 50 kilometers per hour. Now let's see, car B travels the distance of d kilometers in h hours. Based on the equation, 55h is equal to d. All right, now let's see if we can translate this somehow into kilometers per hour. So 55h is equal to d, or we could say d is equal to 55h. And here I'm doing, this is this scenario right over here, not scenario A. And so another way to think about it is distance divided by time. So if we divide both sides by hours, we would have distance divided by time. And so if we have d over h, then we would just be left with 55 on the right-hand side. All I did is I divided both sides by h. Now, this is distance divided by time. So the units here are going to be, we're assuming, and they tell us d is in kilometers, h is in hours. So the units here are going to be kilometers per hour. So car B is going 55 kilometers per hour, while car A is only going 50 kilometers per hour. So far, car B is the fastest. Now, car C travels 135 kilometers in 3 hours. Well, let's just get the hourly rate, or I guess you could say the unit rate. So 135 kilometers in 3 hours. And so we can get the rate per hour. So 135 divided by 3 is what? That is going to be, let's see, we do it in our head, I think it's 45. Let me just verify that. 3 goes into 135. 3 goes into 13 4 times. 4 times 3 is 12. You subtract. You get, 3 goes into 15 5 times. 5 times 3 is 15. Subtract 0. So this is equal to 45 kilometers per hour. So car A is 50 kilometers per hour, car B is 55 kilometers per hour, car C is 45 kilometers per hour. So car B is the fastest. We can calculate the depth d of snow in centimeters that accumulates in Harper's yard during the first 8 hours of a snowstorm using the equation d is equal to 5 times h. So d is the depth of snow in centimeters, h is time that elapsed is in hours. How many hours does it take for 1 centimeter of snow to accumulate in Harper's yard? Pause this video and see if you can figure that out. Alright, so we want to figure out what h gives us a d of 1 centimeter. Remember, d is measured in centimeters. So we really just need to solve the equation 1 centimeter. When d is equal to 1, what is h going to be? And to solve for h, we just need to divide both sides by 5.
Someone's knocking.
So you divide both sides by 5.
Man, my eyeglasses are gone.
Of the h, and you are left with h is equal to 1/5. And the unit for h is hours.
1/5
of an hour. 1/5 of an hour. If they had minutes in there, then you would say, well, 1/5 of an hour, there's 60 minutes, or it's 12 minutes. But they just wanted as a number of hours, so 1/5 of an hour. How many centimeters of snow accumulates in per hour? Or this is a little bit of a typo. How many centimeters of snow accumulate in we could say 1 hour? In 1 hour, or they could have said how many centimeters of snow accumulate per hour? That's another way of thinking about it. So we could get rid of per hour. So pause the video and see if you can figure that out. Well, there's a couple of ways to think about it. Perhaps the easiest one is to say, well, what is d when h is equal to 1? And so we say d when h is equal to 1, when only 1 hour has elapsed, well, it's going to be 5 times 1, which is equal to 5, and our units for d are in centimeters. So 5 centimeters. Let's do another example.
Yeah, cool.
Eddie's Bakery calculates the total price D in dollars for C cupcakes using the equation D is equal to 2C. What does 2 mean in this situation? So pause this video and see if you can answer this question. So remember, D is in dollars for C cupcakes. Now one way to think about it is, what happens if we take D is equal to 2 times C? What happens if we divide both sides by C? D over C is equal to 2. And so what would be the units right over here? Well, we have dollars, D dollars, over C cupcakes. So this would be $2, because that's the units for D, per cupcake.
Insane,
per cupcake. This is the unit rate per cupcake. How much do you have to pay per cupcake? So which of these choices match up to that? The bakery charges $2 for each cupcake. Yeah, $2 per cupcake. That looks right.
Shit, I'm wrong. I thought the
bakery sells 2 cupcakes for $1. No, that would be 2 cupcakes per dollar, not $2 per cupcake. The bakery sells 2 types of cupcakes. No, we're definitely not talking about 2 types of cupcakes. They're just talking about cupcakes generally. Or I guess they're one type of cupcake. We don't know. But just cupcakes generally is $2 per cupcake.
This is 4? Oh, cool. Okay. That's cool. Let's go for. I mean, yes, if this is 4 over 1, okay, and then we could like 1k. Y over x equals k, right? So you have like x 4 and then 3 for y, so we got 3/4. Okay. Y and x 5/4. So when our x is 4, our y would be 5. Ah, okay, P. What's the constant of proportionality? Oh wow, cool. 0.5. Oh, my head. Constant from equations of 3. This one's 3. Equal to 1. 2, okay. Wow, I thought this would be much more harder. From tables with equations. But once find the ratio. Oh wow, this is hard. Okay. So 2 over 22. Say 11. Cool. Okay, I guess that's 9, right? Not really. We have 45 over y. Over 5. Yo, this is insane. So like 5 equals k 45. Yo, okay. Let's solve for this. Let's just solve it. So this is like 1 over 9. Could I just write 1 over 9? Wow, cool. Proportional, okay. Yo, this is exactly the same shit. This is 1. Y. Okay, so we have 15 over 3. It's 1 over 5. Okay. Now, compare constant of proportionalities. Wow, comparison. Okay, let's see. So they assume the greatest amount of flour per serving. Oh shit, what is this? Recipe B. What is this? 9 ounces of flour to make 12 servings of dough. The amount F of flour in ounces to make S servings according to the equation. Okay, so it's just 1.3. So I guess it's supposed to be 3/4. So for every 4, this is like 1.3. What's this amount? What is this amount? 0.75, right? So 0.75. Wait, what? Okay. 14 servings. I guess this is the most. I don't know. I could be wrong. This is hard. This is hard. I'm not getting this one. The greatest amount of flour per servings. Okay, so 14 servings, and we have. I'm going with A. What amount is this use? 14 servings? Okay, so this could be 1 over 9. 3, okay. This one will work. If this one will work as well, 3 answers, either of these. Okay, this one will work as well. So if we have x as 9, then we have 1y. 2, 6, no, this is insane. Yo, this. Wait, what? 1, 9. This work? Isn't this 1, 9? 2/3. Okay, cool. Whatever. So the card is the best fuel efficiency. Ten liters. So for every 2 liters, that is 1 to 10. So we need to have the most liters per, most kilometers per liter. So if this is 10, this will be 120. So I guess C. We should have the same constant of proportion between x and this equation 5 halves. Okay, cool. So I guess if we divide it by 2, we have 2. No. Y equals 5x. Oh shit! How do I? If I multiply this by, I guess. Oh my god, I'm confused. Let's see first. We could do y over 2 equals 5x. Would there be something like that in here? No, not really. We don't have any of that. No, this is hard. Okay. Choose 3 answers. How can I rethink of this in other way? Let's say 5x. No, actually, why did I divide this? We're supposed to multiply this. We have 5y equals 2y is 5x. 2y plus 5x. This is not... Am I crazy or what? Give it 2y equals 5x. So if this is 8, this multiplied by 4, you get 20. Okay, this one works. Then what is this? X is 2. Then it should be 5. Okay, that works. See. Why this doesn't work? Okay. 2 and 1/2. Okay, this should work. Y is 2, 10. Okay, this works well. Oh wow, I got that. Cool. I would have never. That's insane. Okay, let's see. Evelyn, Neil, and Leilani swing laps at a constant rate. Select the swimmer who swims the fastest. No. So 54 seconds for the first guy, and then Neil is 1 to 65. 40. Okay. Wow. Okay. 30 seconds for just one lap. You're actually the fastest. Leyland. We have the same question between y and x as following instead. Okay. So for y, we have 7, 2, or 3/5 for each one. So 4, 7, 14. Yeah, that works. Yeah, that works well. Am I overthinking this? This is 1 over here. Divide it. We have like 5y over x and then 1. There. Pretty sure it could be, that would be right. Let's look at solve. This is my scene. 2 would be 7, and this is 7, 2, 7. Okay. I guess I'm done. This is 1, 4, no. 4, 14. Yo, this is 14. This is insane. So this could be wrong? Which could be wrong? Which could be wrong? This one? Ah, yeah, this one's wrong. I almost got debated by it. God, insane. I almost got debated by this shit. Wow. I mean, if multiplied by x, I mean, for every oh shit, I could be wrong. I need to rethink this. We have y to oh my god, 7 2, right? So 3.5 or 1. So if our y is 4, then our x will be smaller, right? That's actually correct. So if our y is 7, we would have 2. Okay. And then if our y is 14, we would have 4. Okay. Alright, this makes sense. What? Oh my god. Are you kidding me? Is this one really for it? Oh my god. No way. So what is this for? Oh my god. Okay, 7. Okay, 14. Just 2 over 7. I'm so confused right now. Why is that the case? So if we search for it would 3.5 y over x equals 1. Why does this work in that fashion? This is insane. I mean, if you plot this 3.5 here, then we have x of 1. That makes sense. It's just insane. I'm not convinced about this. This one makes sense. Am I supposed to say that the actual y itself is 7? So we're gonna have like 4 times 7. Or is it supposed to be like, this is insanely hard. Oh man, I'm not convinced. So this is 7 literally, oh my god, I can't even write over there. 7 over 2. Or we could do 7 equals 2x. 7y equals 2x. I'm not sure. Am I supposed to do y over here, then 2x over there? And for every no. Least expensive corn per ounce. So we have like this is I guess is x and y, I guess. So we have 1.5. Are we going to find like this proportionality shit thing? Oh my god, this is insanely hard. So 1.5 to go from this is like twice. This is wait, what? Let's say 36 divided by 3, which would be 12. Right. Oh man, I need to watch the videos. I'm still confused about the stuff. Can you please let me use a calculator? Will this work? I'm so confused. This is 6 over 2, right? Or 1/3. So it has a proportionality of 3. So 9 divided by 3 is 3. This would work. And 15 divided by 3 as well. Insane. 1/3. Oh, okay. Oh, that makes sense. But I was able to convert it earlier. Like, this is 6 over 2, then equals x. Wait, what? Let's see. Let's draw over 6y equals x. And then multiply both sides by 2. You have 2x equals 6x, or 3 equals x, or 1. Yeah, this has make sense. Wait, it actually does. Because 3y You have 3y already and then 1x. Damn, this is getting confused. Doesn't make sense to me at all. Why am I saying y over here when this should be like x? Because this is actually the proportionality. So y, this 6 over 6 actually the y, and then the 2 is the x. This is insanely hard, man. I'm only drinking water this time. Who earns the most per hour? It's 448, 12 per hour. 12 per hour. George earns the most per hour. Oh, so if you divide both sides by h, we have like earnings per hour, which is 8.75. Why do I think that I have to divide it by to get like hours? Oh, I don't know. It's a different unit, this thing. Okay. Okay, so it's like 1/4. So 4, just 1. One fourth. So yeah. So if our y is 0.20. Just say 1 equals 4. So if our y is just 1, no, it doesn't make sense. If our x is 4, you have 1. Now if our x is 4, 6, you have 1.5. The answers. Oh, this is actually incorrect. Why am I basing this answer from this graph? 8x to y. What x to y? So, I'm not sure. This is a constant proportionality 1/4, right? 1/4. Let's see again. If our y is equals to 1, then we have 4x, like that. No, this is, am I supposed to write it like this? This is incorrect, I'm supposed to say 1/4, and then this equals like just 1. So if we do 1/4, basically, oh my gosh. How do I think of this in a different way? If I just say like 8, to divide by 8, I would get 0.25x. Yeah. Least expensive ice cream per scoop. So we have $75 per scoop over here. This is 1-to-1. And this is for every one scoop, you have about 1 point something. Or two scoops, $3 per scoop. So this is the least. Hey. Constant of proportionality for this guy is 6/8 or 3/4. So y equals 3/4 x. This is the concept of proportionality for this guy. Right? Okay, I could think of it in this way. This is much more better. Okay. Let's see. Choose two answers. Okay, this one works. It's actually what I wrote out there. So we have to. Oh my god, this is hard. Just two answers. Oh my gosh. Okay. If you multiply this by 4, we get 3. So 4 and then 3. 4y. 3x. Okay, 3x for y. Does this work? I don't know. And this is actually the reciprocal. Well, where is the correct one? Multiply this by 4, get 4y, and then 3x. Am I supposed to think like that? Oh my god, I'm not sure. I don't know about this. Well, let's go. Oh, I knew it. I knew I'm wrong. It could be this guy, let's see. Oh man, why? Why? So we have y equals 3/4. Oh my god, this is insane. If you multiply both sides by 4, this would die. You get 4y equals 3x. 4y and 3x. I am so confused, motherfucks. Why does that work? They are apparently I'm not supposed to do it like that. If I have like 3y and then our fourths within 3/4 of that to get the same amount. That makes sense. So multiply this by 4. This is 3. 4 left with 3. Okay, that makes sense, but that's hard to think like that. Let's see how I can think of this in a different way. Four-thirds. How did you know that's 4/3? 6, 8. No, it isn't supposed to be like that. The relationship of the constant of proportionality to 4/3. Okay, I'm gonna solve for this guy, I guess. So divide by 6. 8, 6, and we have like 4/3. Okay, cool. That makes sense. 34. So I'm not supposed to plug in this bullshit into that. I'm not. Or am I? Actually, I am supposed to do it there, but I'm not supposed to use it as some kind of... okay, this is making my brain go die. I'm still confused. Let's think of a way why this would work. Okay. When x is 4 and y is 3. Have 3/4 x, y. So if this is 4, then I guess that would cancel out. We have y equals 3. Okay, that makes sense. You just plug in the number and then solve for the bullshit, I guess. This is 30, right? No, not really 30, this is actually 60. No, it's 30. No, wait, what? 200 words per minute. It will divide that by 5. Oh my god, I don't even know. What the fuck? 30 times 10 is 300, so I guess it's 60 times 10. So 120 times 5. Okay. It's 120. 120 words per minute. Or it is 140 words per minute. Arial is at 150. Half. Okay. Let's see. Divided by 6. Okay, it's a half. Let's see. If this is 2/4. Okay, that's a half or so. And then what is this? This is y 4/2. No. It's just 2. This is just 2. No. So, okay, this bullshit again. Okay. So, if our y 1/2. Are you kidding me? I fell for the same bullshit again? Oh, it's not proportional. Oh man, it is not. This one's proportional. Oh my god. Okay, this is insanely sick. Travels the fastest. This is 50. This is 55. It's like 55 per hour. 2 is 45% speed. Constant of Proportionality is 30/4. Or this is 8/1. Or just 8. Then 24 divided by 4. 28, it's 8? Yeah, that's 8. Okay, cool, that's 8. So, this one we have... What is this? This is 2 divided by 3, no. Okay, this is 8/1. Okay, that works. 3 answers, 1 more. Oh, this shit again. 16 divided by 2. And 4, okay. Finally I'm getting it. But I still have to work. Okay, it's pretty much bullshit. We're 40 minutes in and not making progress. I'm still stuck. Ernest composed of 3 pizza, his pizza dough. The greatest amount of, oh shit, I've already solved this, is A. Okay, 1/2. Alright, this is 1/2. Oh my god, I solved this shit. This is 2/4, that's half. Yeah, it's 2/4, or 1/2. Okay. Oh, it's B. Oh my god, I've already solved this shit again. Okay, 3. This is, no, this is correct, 1. Y, okay. And this one, I believe, 2, wait. This is insane. Maya shaved her head and then began letting her hair grow. She reckons the length of L of her hair in centimeters. And months after shaving her head using the L. Oh, okay. It's the length per month. The grass in Jane's yard grew 16 centimeters in 10 days. Constant rate. Oh my god, how do I? In 10 days. To grow 1 centimeter. Holy shit, this is insane. Okay, so multiply by 16, I guess. Then divide by 16. How much 16 do we need? What about 5/16? We have 33, 8. Okay, we can do one more. So 16 times 6, 36, 3, 6, 96. So we can do 6 and then 96. And then we will have it 4 and then 0. We can do 32. And then 8. 0.625 days. How many meters did the grass grow in one day? 1.6. Zen is an audiobook narrator. The table gives some completed audio lengths and the amount of time Zen spends. Zen is an audiobook narrator. The table gives some completed audio lengths. Sometimes Zen spends. Oh, is this supposed to be a person? Holy shit, I thought it was kind of a device. An audiobook narrating device. I guess it's a person, I guess. Time spent. Okay. Okay. 6.5 mean in this situation. Parse. What? 6 and working time. Completed of audiobook hours. Oh, okay, this makes sense. No. Caris calculates the total amount E in dollars, and she earns for working. How many dollars earned per hour? She earns 10 per hour. At that rate, how many hours does it take Caristers to earn $1? 1 divided by 60. 1 divided by... Oh gosh, this is hard. Okay, so 1 hour divided by 10? Wait, what? That's just 0.1 hours? I don't know. They're so weird. Okay, one more. Interpret constant of proportionality in graphs. Okay. Per hour you walk for 5 kilometers. How long does it take 1 kilometer? I guess 0.2 hours? Let me guess K. Gavin's hamster to eat it. Gavin hamster food. That is the mass of the hamster food. No. Once every 30 days. How makes a snack mixed with proportional amounts of cereal and popcorn? Okay, so for every 1 we have 2, okay. So it's our constant proportionality. Or just 2, like y equals 2x. How many cups of popcorn does Solomon use per cup? How many per cup? We have 2 per cup. 2 cups. Wait, what? Popcorn per cup of cereal. Alright, it's 2 cups. How many cups of cereal does Solomon use per cup? How many cups of cereals per cup of popcorn? So if this is so it's gonna be half 0.5 cups. Okay, cool. This is insane hard. This is hard. Okay. This be easy. Constant of proportionality. So we have y over 4 or 3 over 2. Oh my god, if I'm wrong with this, I'm gonna kill myself. Okay. The 3 lines represent the distance traveled kilometers with 3 cyclists. Which cyclist is slowest? Okay, it's gonna be O. It's gonna be O. .75 per scoop, 1 to 1, and this is 1.5 per scoop. So this is the least expensive. Solomon is 3D printing chess pieces. The table gives the amount of time needed to print certain number of pieces. 1 piece, 16 minutes. Okay. So this is 16. What does 16 mean in this situation? 16 minutes to print each chess piece. Each chess set Solomon prints 16 contains 16 pieces. What? No. 36 over 12, or 3 or 1, or just 3. Yeah. So constant proportionality equal to 5. No, this is more straightforward. This is 5. This is half. There's no sound of that. Cool. That's for that quiz. Okay, next. Identifying proportional relationships. Wow, this is hard. Okay, let's see how much we're recording. A few minutes, and plus the first recording, you're not good.
An hour and 5 minutes.
Now let's do identifying proportional relationships. This is really hard.
I want to introduce you to.
I'm just gonna grab some water.
In this video is the notion of a proportional relationship. And a proportional relationship between two variables is just a relationship where the ratio between the two variables is always going to be the same thing. So let's look at an example of that. So let's just say that we want to think about the relationship between x and y. And let's say that when x is 1, y is 3. And then when x is 2, y is 6. And when x is 9, y is 27.
Yep.
Now this is a proportional relationship. Why is that? Because the ratio between y and x is always the same thing. And actually the ratio between y and x, or you could say the ratio between x and y is always the same thing. So for example, when we say the ratio y over x, this is always equal to, it could be 3 over 1, which is just 3. It could be 6 over 2, which is also just 3. It could be 27 over y, which is also just 3. So you see that y over x is always going to be equal to 3, at least in this table right over here. And so in this is the data points we've just seen. So based on this, it looks like we have a proportional relationship between y and x. So this one right over here is proportional. So given that, what's an example of relationships that are not proportional? Well, those are fairly easy to construct. So let's say we have, I'll do it with 2 different variables. Let's say we have A and B. A and B. Let's say when A is 1, B is 3. And when A is 2, B is 6. And when A is 10, B is 35. So here, you might say, oh, look, when A is 1, B is 3, so the ratio between, for the ratio B to A, you can say B to A, when B is 3, A is 1, or when A is 1, B is 3, so 3 to 1. And that's also the case when B is 6, A is 2, or when A is 2, B is 6, so it's 6 to 2, so these ratios seem to be the same, they're both 3. And then all of a sudden the ratio is different right over here. This is not equal to 35 over 10. This is not equal to 35 over 10. So this is not a proportional relationship. In order to be proportional, the ratio between the two variables always has to be the same. So this right over here, this is not proportional. Not proportional. So the key in identifying a proportional relationship is look at the different values the variables take on when one variable is one value and what does the other variable become, and then take the ratio between them. Here we took the ratio of y to x, and you see y to x, or y divided by x, the ratio of y to x is always going to be the same. This is proportional. And you could actually run the other way. You could have said, well, what's the ratio of x to y? X to y? Well, over here it would be 1 to 3. 1 to 3, which is the same thing as 2 to 6, which is the same thing as 9 to 27. 9 to 27. When you take this ratio, between, if you say the ratio of x to y, y to x, you see it's always 1/3. Any way you look at it, the ratio between these two variables is y to x, it's always going to be 3, or x to y is always going to be 1/3. So this is proportional, while this one is not. The following table describes...
Oh, sec, I'll be back in a minute. Alright, I'm back! God damn it, I'm insane.
The following table describes the relationship between the number of servings of spaghetti bolognese.
Spaghetti bolognese? I have no idea what that is.
To prepare them. Test the ratios for equivalence and determine whether the relationship is proportional. When you have a proportional relationship between the number of servings and the number of tomatoes is if the ratio of the number of servings to the number of tomatoes is always the same, or if the ratio of the number of tomatoes to the number of servings is always the same. So let's just think about the ratio of the number of tomatoes to the number of servings. So it's 10 to 6, which is the same thing as 5 to 3. So here the ratio is 5 to 3. It's 15 to 9. If you divide both of these by 3, you get 5 to 3, so it's the same ratio. 15 to 25, if you divide both of these by 5, you get 5 to 3.
Wow.
So based on this data, it looks like the ratio between the number of tomatoes and the number of servings is always constant. So yes, this relationship is proportional.
Can you do that again?
Have a proportional equivalence of the number of servings of things. So it's 10 to 6, which is the same thing as 5 to 3. So here the ratio is 5 to 3. It's 15 to 9. If you divide both of these by 3, you get 5 to 3. So it's the same ratio.
Bananas.
Today, Nate has 100 bananas. He will eat 2 of them every day. Is the number of bananas Nate has left proportional to the number of days that pass? I encourage you to pause this video and think about this. And what's interesting here, they're not saying is the number of bananas eaten. They're saying the number of bananas Nate has left proportional to the number of days that pass. So let's draw a little table here to think about this a little bit. I'll make 3 columns.
Wow, nice, it's straight.
So in the first column, this is going to be the number of days that pass. The days, number
I guess
of
it's
days
proportional. Yeah, I guess it's proportional.
pass. So that's this right over here, the number of days pass. And this middle column, I'm going to write the number of bananas Nate has left. Number of bananas left. And over here, I'm going to make the ratio between the two. In order for this to be a proportional relationship, the ratio between these two has to be constant. So, bananas left. So I'm going to divide the second column by the first column. Bananas left, divided by days passed. Days passed. All right. So let's think about it.
I guess not.
When 1 day has passed, how many bananas will you have left? Well, that 1 day he will have eaten 2 bananas, so you're going to have 98 bananas left. And so what's the ratio of bananas left to days passed? It's 98 over 1, which is going to be equal to 98. All right. When 2 days have passed, how many bananas is he going to have left? Well, he's going to consume 2 more bananas, so he's going to have 96 left.
96.
And so what's the ratio? It's going to be 96 to 2, which is equal to 40. So clearly this ratio is not constant. It changed just from going from 1 day to the next day. So we don't have a constant ratio of bananas left to days passed. So this is not a proportional relationship. Now, things might have been a little bit different. They said the number of bananas Nate has eaten, is that proportional to the number of days that passed? Well, yeah, sure, because then if this was the number of bananas eaten, then it would always be 2 times the number of days that passed. So that would be 2, and that would be 4. And then the ratios would always be 2, but that's not what they asked for. They wanted us to compare the number of bananas left to the number of days that passed.
Cool. Okay. Movie tickets.
A movie theater charges $10.50.
10 R. Let's make it 2 R's.
per ticket, and $5 per bucket of popcorn. You never buy the popcorn because you think it's too expensive. Is the total price you pay proportional to the number of tickets you buy? Alright, this is interesting because they tell us the price of a popcorn, they tell us the price of a bucket of popcorn, but then they tell us that we never buy the popcorn. So I guess I don't know why they tell us what the price is, maybe to confuse us. So is the total price you pay proportional to the number of tickets you buy? Well, you're only buying tickets, you're not going to be buying any popcorn. So yeah, you're going to spend $10.50 for every ticket. So it should be proportional. And just to see that a little bit clearer, let's draw a little table here. So number of tickets, and then price, the total price. We're assuming I never buy the popcorn. So if I buy one ticket, the price is going to be $10.50. If I buy two tickets, it's going to be 2 times $10.50, or $21. If I buy 3 tickets, it's going to be 3 times $10.50, which is what, 31.
Would that be just 20.6? That's insane.
And so you can see the ratio between
It's actually 15, not 3.
price and number of tickets. It's always going to be 1050. 1050 divided by 1, and 1 divided by 2, 3150 divided by 3. It's always going to be 1050. Well, that's because the price, or another way, the price is just going to be 1050 each times the number of tickets. So clearly a proportional relationship.
Alright.
Mixes 15 milliliters of bleach with 3.75 liters of water to make a sanitizing solution for daycare. The amounts of bleach and water always have to be proportional when he makes the sanitizing solution. Which of the following could be combinations of volumes of bleach and water for Mael's sanitizing solution? And they give us 5 potential combinations. They say pick 3. So I encourage you to pause this video and try to figure it out. Remember, he mixes 15 milliliters of bleach for every 3.75 liters of...
Wait a second. Okay, I'm back. I got my eyeglasses back and some noodles. Some cheap ramen noodles.
Water. So I'm going to make it water. Alright, now let's try to work this together. So I'm going to make a table. So let's say this is bleach. Bleach in milliliters. Let's say this is water in liters. And they tell us that
I want to start the whole thing.
We're told that Mael mixes 15 milliliters of bleach with 3.75 liters of water to make a sanitizing solution for daycare. The amounts of bleach and water always have to be proportional when he makes the sanitizing solution. Which of the following could be combinations of volumes of bleach and water for Mael's sanitizing solution? And they give us 5 potential combinations. They say pick 3. So I encourage you to pause this video and try to figure it out. Remember, he mixes 15 milliliters of bleach for every 3.75 liters of water. Alright, now let's try to work this.
0.0001.
So let's say this is bleach. Bleach in milliliters. Let's say this is water in liters. And they tell us that he mixes 15 milliliters, with the liters, milliliters, for every 50 milliliters of bleach for every 3.75 liters of water. So what is the proportionality constant here? If you said the water is equal to some constant times the bleach, well, what's going on? Well, let's see. What would he have to multiply by? He would have to multiply by 3.75 over 15. Now, what is 3.75 divided by 15? Let me actually do it right over here. 15 goes into 3.75. let's see, 15 goes into 37 2 times. That's more over here. 2 times 15 is 30. Subtract 7. Let's see, 7. Bring down to 5. And then 15 times 5 is 75. 5 times 15 is 75. And it all works out. So we see to go from bleach to water, we're multiplying by a proportionality constant of 0.25.
1/4.
0.25. So we have to see which of these have the same exact proportionality constant going from bleach to water.
Wow, A
So
works.
let's see, this next
B
one
works.
is 12 and 3. So if we multiply 12 by 0.25, do we get 3? Yeah, 3 is 1/4 of 12. 0.25, 25 is the same thing as 1/4. So this one checks out. What about going from 6 to 1.5? Are we multiplying by 0.25? Yeah, 1.5 is 1/4 of 6. Or another way to think about it is, what is 6 times 25? It is 150. So 6 times 25 hundredths would be 150 hundredths, which is the same thing as 1.5. So this one works. What about 3 and 0.75? 3 and 0.75. Am I multiplying by 0.25? Yeah. If I multiply 3 times 25 hundredths, I get 75 hundredths.
Yeah, it works.
So that works. So actually, the first 3 choices are our 3 answers. Let's just verify that the next 2 are not good answers. So let's see. If I go from 20 to 5.5, and so am I multiplying by 0.25? No, 0.25, which is the same thing as 1/4. 1/4 times 20 is 5, not 5.5. So that doesn't work. And then going from 11 to 3.75. Well, we definitely know that's not going to work because notice we have the same amount of water, but we have less bleach. Or you could say, well, what's 1/4 of 11? Well, that's going to be less than 3.75. So we can rule both of these choices out. We're asked to solve the proportion. We have 8/36 is equal to 10 over what? Or 8 to 36, or the ratio of 8 over 36 is equal to the ratio of 10 to what? And there's a bunch of different ways to solve this. I'll explore really all of them. Or not all of them, but a good selection of them. So one way to think about it is
Those in real times 4 of them. This is, if it's 4, it's going to like 30.
these two need to be equivalent ratios, or really equivalent fractions. So whatever happened to the numerator also has to happen to the denominator. So what do we have to multiply 8 by to get 10? Well, you could multiply 8 times 10 over 8 will definitely give you 10. So we're multiplying by 10 over 8 over here. Or another way to write 10 over 8, 10 over 8 is the same thing as 5 over 4. So we're multiplying by 5 over 4 to get to 10, from 8 to 10. Well, if we did that to the numerator, in order to have an equivalent fraction, you have to do the same thing to the denominator. You have to multiply it. You have to multiply it times 5 over 4. And so we could say this n, this thing that we just solved for, this n is going to be equal to 36 times 5 divided by 4. Or you could say that this is going to be equal to 36 times 5 divided by 4. And now, 36 divided by 4, we know what that is. We can divide both the numerator and the denominator by 4. You divide the numerator by 4, you get 9. Divide the denominator by 4, you get 1. You get 45. So that's one way to think about it. 8 over 36 is equal to 10 over 45. Another way to think about it is, what do we have to multiply 8 by to get its denominator? How much larger is the denominator 36 than 8? Well, let's just divide 36 over 8. So 36 over 8 is the same thing as, so we can simplify dividing the numerator and the denominator by 4. That's their greatest common divisor. That's the same thing as 9 halves. So if you multiply the numerator by 9 halves, you get the denominator. So I'm multiplying by 9 halves to get the denominator over here. Well, then we have to do the same thing over here. If 36 is 9 halves times 8, let me write this. 36, or let me write 8 times 9 halves is equal to 36. right? That's how we go from the numerator to the denominator. Then to figure out what the denominator here is, if we want the same fraction, we have to multiply by 9 halves again. So then we'll get 10 times 9 halves is going to be equal to 10. Is going to be equal to this denominator. And so this is the same thing as saying 10 times 9 over 2. Divide the numerator and the denominator by 2, you get 5 over 1, which is 45. So 45 is equal to n. Once again, we got the same way. Completely legitimate way to solve it. Now sometimes when you see a proportion like this, sometimes people say, oh, you can cross multiply. And you can cross multiply, and I'll teach you how to do that, and that's sometimes a good way to do it. But I don't like teaching it the first time you look at proportions, because it's really just something mechanical. You really don't understand what you're doing, and it really comes out of a little bit of algebra. And I'll show you the algebra as well. But if you don't understand it, if it doesn't make as much sense to you at this point, don't worry too much about it. So we have 8 over 36 is equal to 10 over n. When you cross multiply, you're saying that the numerator here times the denominator over here is going to be equal to, so 8 times n is going to be equal to the denominator over here, I'll do this in a different color, the denominator over here times the numerator over here. This is what it means to cross multiply. So this is going to be equal to 36 times 10, 36 times 10. Or you could say, let me use a neutral color now. You can say that 8n is equal to 360. And so you're saying 8 times what is equal to 360? Or to figure out what that times what is, you divide 360 divided by 8. So we could divide, this is a little bit of algebra here, we're dividing both sides of the equation by 8, and we're getting n is equal to 360 divided by 8. And you can do that without thinking in kind of strict algebraic terms. You say 8 times what is 360? Well, 8 times 360 over 8. If I write 8 times question mark is equal to 360, well, question mark could definitely be 360 over 8. If I multiply these out, this guy and that guy cancel out, it's definitely 360. And that's why it's 360 over 8. But now we want to actually divide this, so that you get our right answer, or a simplified answer. 8 goes into 360. 8 goes into 36 4 times. 4 times 8 is 32. You have a remainder of 4. Bring down the 0. 8 goes into 45 times. 5 times 8 is 40, and then you have no remainder. And you're done. Once again, we got n is equal to 45. Now the last one I'm going to show you involves a little bit of algebra. If any of the ways before this work, that's fine. And where this is sitting in the playlist, you're not expected to know the algebra, but I want to show you the algebra just because I wanted to show you that this cross multiplication isn't some magic. That using algebra, we will get this exact same thing. But you can stop watching this if you find this part confusing. So let's rewrite our proportion. 8 over 36 is equal to 10 over n. And we want to solve for n. Well, the easiest way to solve for n is maybe multiply both. This thing on the left is equal to this thing on the right. So we can multiply them both by the same thing, and the equality will still hold. So we can multiply both of them by n. On the right-hand side, the n's cancel out. On the left-hand side, we have 836 times n is equal to 10. Now, if we want to solve for n, we can literally multiply. If we want just an n here, we want to multiply this side times 36. Do that in a different color. We want to multiply this side times 36 times 8. Because if you multiply these guys out, you get 1, and you just have an n. Because we're doing it to the left-hand side, we also have to do it to the right-hand side. So times 36 over 8. These guys cancel out. And we're left with n is equal to 10 times 36 is 360 over 8. And notice we're getting the exact same value that we got with cross multiplying. And with cross multiplying, you're actually doing 2 steps. Actually, doing an extra step here. You're multiplying both sides by n, so that you get your 8n, and then you're multiplying both sides by 36, so that you get your 36 on both sides, and you get this value here. But at the end, when you simplify it, you'll get the exact same answer. So those are all different ways to solve this proportion. Probably the most obvious way, or the easiest way to do it in your head, was, well, either just looking at what you have to multiply the numerator by, and then doing the same thing to the denominator, or maybe by cross multiplication. rise to some.
Oh shit, I'm supposed to do this now.
Right.
So I'm just gonna finish my food, then I'm gonna continue answering. Alright, I'm back. Alright, so Gamer Services for stream video games free for each game after that. You should know, right? The following table shows the height of a plant at different ages. From 3 to 12 to 4, this is like 5 though. No. Cam is a corrupt politician. Nobody votes for him except those he pays to do so. Holy shit. It costs Cam exactly $100 to buy each vote. Yep. Insane kind of example, dude. Thus the following table shows a proportion between the variable x and y. Oh shit. Holy shit. Type this. What is this? 5, 6, and then goes to 2. So, how much you multiply this? So, if you multiply by, am I supposed to say 2, 6? Doesn't make sense though. Oh my god, I don't know. There's 6 and then 10. So, what's this? No, it's clearly not 2. Also survive 6 times 8 is 48. We get 20, 3, 18. Okay, so that's an amount that we get. Oh my god, what the fuck? This looks like no though. There's this thing right here. Oh man, let's see how we do this. To divide by 5, 6. It's the same thing as multiplying by its reciprocal. So it's gonna be 12. 12 bits. So that would be the same thing for 10. So you have 10 times 6, 25. 60 over 25. We can do it by 5, so we have 5 here and then. Cool. Wow. Anna does sit-ups to get ready for her first triathlon. When she starts you're making lemonade. The amount of sugar in it depends on the amount of lemonade mix you use. Okay, let's see. I would say yes. Instinctively it does, but let's calculate it anyway. So we get 1/3 or 1/6. Let's see if wait, what? 1/3 times 1 is still 1/3. So wait, what? Multiply 1/3 by 1, you get 1/3. Multiply 1 by 3, you get 3. Why am I multiplying it? It should be 1/3 times 1. Or 1 divided by 3, you get 1/3. 3 divided by 9 is 1/3 still. Very cool. A movie theater charge. Oh, okay. Part of the exercise the video solves. Times 3 times 6. No. No. Oh shit, your total savings. Oh my god. I hate myself. 4, 1/4. Oh, not actually 1/4. This is 1/8. This is 1/8. Oh my god, this is insanely hard. No, this is wrong. This is wrong. What is this? Total mass, I guess. Two times 3. Yo, what?
1/4 times 1/3. Why am I multiplying? Oh, because I'm supposed to be dividing, so 1/4 times 3, which would be 1/3. Which would be the same as multiplying, but it's reciprocal. 1/3. So we have 1/12. And then we have 2/4 times its reciprocal 1/6. So we do 2 over 24, 1/12. Okay, cool. So we have 3/4 times its reciprocal 1, 9. 3 and 36 divided by 3 is still 1 thing. Okay. Okay, I keep on making one mistake. I hate it. Oh wait, what? Adrian savings account balance. Oh man, yeah, but starting with 28, it's gonna mess things up. Each week he deposits another $15 into that. Oh man, this is insane. I can be wrong again. Thank you. Jimmy just receives his first year. No. No. Each liter of gas costs $3. Versus a promotion at every beverage you purchase to save. Insert the total savings in gas proportional to the number of beverages you purchase. Total savings, right? Oh yeah, okay. Oh man, okay. Wait, what? Isn't this the same thing from earlier? This is yes, right? Oh yeah, this is 1/4. Oh yeah, that's the actual thing. Movie theater charge. Yeah. GNH. Okay. Times 3. This is some 6 and 7 ones, no. Wow, cool. So for everyone we have 25. No, actually it's not it. It's not rates. We're in proportions. So 2 divided by 50. So 20 is no as well. So 200. So let's see if this actually works for that. So we have 0.4 divided by 10. So no. Wow, cool, okay. Oh my god, you have to do each one of these. If this is 4, so 60, so no. First one is a no. Second one is 0.8, 25, 80, 0, 0. I figure 4 it's 100, so no. So no. 1.6. 40, 0, 160, 84. Okay, that works. One more answer. Okay, 1.4. I think 35 seems cool. Say 1.4
4, 35, right? So 0, 0 there. And then, oh yeah, that's 4 as well. So like 17, okay, cool. There we go. Triangle A is a height of 2.5 centimeters anyways. Well, the height and base of triangle B to the height and base of triangle A. Okay, so let's see, 1.6 divided by 2.5. So, no. We could do 6, 4, 150, and 0.064. It's insane. Let's see. Oh man, I want to do a calculator on this. Oh my god, do I really have to do the small numbers? Oh man, I'm gonna kill myself. Okay. Oh shit, we have a calculator, oh my god. 1.6 divided by 0.64. Wow, why did I get 0.064? Oh, I didn't account for that. Yeah. Oh shit, I didn't account for it though. 0. Yo, that's insane. Let's do 1.6 just out of curiosity divided by 2.5. So this is 0, right? And our shit goes there. The same shit if we just do that. Whoa. If I do like 2.5, 1.6, and then 25 divided by 1.6. Not 1.6 actually. 16. So 0, but 6 times. Yeah, but from this perspective, it's already 0 in here, and then 1.6 already 0. So I have to do it from this far. Wow. This actual is different shit. Okay. Anyway, let's just move on. 1.76 divided by 2. Okay, this one works. 9.16. Clearly not. So the base should be smaller. No. This is smaller. 0.8 divided 1. This is really a process of elimination, I guess. So 1.28. That doesn't make sense.
So we have, am I supposed to weigh 60 divided by 580? Wow, cool. To make a search. Orange. Okay. Let's see, 28. Or 2.6. Would that be true for this one and for the other? Okay, so the second one should be larger, so 5. No. Just looks like it could work. Oh, yeah. 2 answers. No. Oh, this one would work. 16.7. Well, not really. 12 divided by 4. Rectangle A is adding of 3. Okay. 3.5. Divided by 12. Wait. This shouldn't be it. It's 0.5, obviously. 5 divided by 12. Okay. Yo, only answer A would work in this case. More than half. Strange. Rotation. So we have 3 out of 150 did not pop. Okay, cool. Let's see, how long have we been recording? Okay, not enough hours, so let's do some more.
I have 3 word problems here. What I want to do in this video is not solve the word problems, but just set up the equation that we could solve to get the answer to the word problem. Essentially, we're going to be setting up proportions in either case. So in this first problem, we have 9 markers cost $11.50. And then they ask us, how much would 7 markers cost? Now let's just set x to be equal to our answer. So x is equal to the cost of 7 markers. The cost of 7 markers. So the way to solve a problem like this is to set up 2 ratios and then set them equal to each other. So you could say that the ratio of 9 markers to the cost of 9 markers, so the ratio of the number of markers, so 9 to the cost of the 9 markers to 1150, this should be equal to the ratio of our new number of markers, 7, equal to the new number of markers, so that's 7, to whatever the new cost, or whatever the cost of 7 markers are, 2x, x in green, 2x. So this is a completely valid proportion here. The ratio of 9 markers, or the cost of 9 markers, is equal to 7 markers to the cost of 7 markers, and then you could solve this to figure out how much those 7 markers would cost. And you could flip both sides of this and it would still be a completely valid ratio. You could have 1150 to 9. So the ratio between the cost of 9 markers, the ratio between the cost of the markers to the number of markers you're buying is equal to, so 1159 is equal to the cost of 7 markers is equal to 7 markers, is equal to the ratio of the cost of 7 markers to the number of markers, which is obviously 7. So all we did is flip both sides of this equation right here to get this one over here. You could also think about the ratios in other ways. You could say that the ratio of 9 markers to 7 markers, the ratio of 9 markers to 7 markers is going to be the same as the ratio of their cost. Is going to be equal to the ratio of the cost of 9 markers to the cost of 7 markers. And then obviously you could flip both of these sides. So you could say the ratio of 7 markers, then same magenta color, the ratio of 7 markers to 9 markers is the same thing as the ratio of the cost of 7 markers to the cost of 9 markers. So that is 1150. So all of these would be valid proportions, valid equations that describe what's going on here, and then you would just have to essentially solve for x. So let's do this one right over here. 7 apples cost $5. How many apples can I buy with $8? So once again, we can say, so we're going to assume that what they're asking is, how many apples, let's call that x. X is what we want to solve for. So 7 apples cost $5. So we have the ratio between the number of apples, 7, and the cost of the apples, 5, is going to be equal to the ratio between another number of apples, which is now x, and the cost of that other number of apples, and it's going to be $8. And so notice here, in this first situation, what was unknown was the cost. So we kind of had the number of apples to cost, number of apples to cost. Now in this example, the unknown is the number of apples. So number of apples to cost, number of apples to cost. Now we can do all of the different scenarios like this. You could also say the ratio between 7 apples and x apples is going to be the same as the ratio between the cost of 7 apples and the cost of 8 apples. And obviously you could flip both sides of these, either of these equations, to get 2 more equations. And any of these would be valid equations. Now let's do this last one. So we have a cake recipe for 5 people. I'll use new colors here. A cake recipe for 5 people requires 2 eggs. It requires 2 eggs. How many eggs? So we want to know how many eggs. So this we'll call X. And you don't always have to call it X. You can call it E for egg. Well, E is going to be another number that you get to higher mathematics. But you could call them Y or Z or any variable. A, B, or C, anything. How many eggs do we need for a 15-person cake? How many eggs do we need for a 15-person cake? So you could say the ratio of people to eggs. So the ratio of people to eggs is constant. So we have 5 people for 2 eggs. Then for 15 people, we are going to need X eggs. This ratio is going to be constant. 5 over 2 is equal to 15 over X. Or you could flip both sides of this. Or you could say the ratio between 5 and 15, the ratio between 5 and 15 is going to be equal to the ratio between the number of eggs for 5 people. Let me do that in that blue color. The ratio between the number of eggs for 5 people and the ratio of and the number of eggs for 15 people. And obviously you could flip both sides of this equation. So all of these, we've essentially set up the proportions that describe each of these problems. And you can go later and solve for X to get the answer. We're told that Rika can eat 21 hot dogs in 66 minutes. She wants to know how many minutes M would it take her to eat 35 hot dogs so she can keep up the same pace. So big clue is the same pace. A big clue is the same pace. That means that the hot dogs per minute is going to be constant. Is always going to be the same. Always the same. Because this is essentially the pace. But hot dogs per minute are going to stay the same. It's going to stay the same pace. So it tells us that she can eat 21 hot dogs in 66 minutes. So her hot dogs per minute, I think it's up here, is 21 hot dogs in 66 minutes. So 21 hot dogs in 66 minutes. Well, if her pace is always going to be the same, well, it's going to take her, this ratio over here is going to be the ratio between 35 hot dogs and however long it takes her to eat 35 hot dogs. So once again, hot dogs per minute, it has to be a constant, so it's going to be the same pace. Hot dogs per minute. If it takes 21 hot dogs, it takes 66 minutes, 35 hot dogs take 10 minutes, these two ratios are going to be the same. We're dealing with a proportional relationship. It's going to be happening at the same rate. And then we're left with a situation where we just have to solve for M. And there's a bunch of different ways you can tackle this. The easiest way that I can think of doing it is, I don't like this M sitting here in denominator, so let's multiply both sides by M.
Wow, it's a bit of an algebra.
By M, and this side by M. And so what do we get? On the left-hand side, we have 21 over 66M. 21 over 66 times M is equal to, well, you divide by M and multiply by M, those are going to cancel out, you're just going to have 35. And now you just have to solve for M, and the best way I can think of doing that is multiply both sides times the reciprocal of the coefficient on the M. So let's multiply both sides by 66 over 21. Once again, I've just swapped the numerator and the denominator here to get the reciprocal, but I can't just do it for one side of the equation. I have to do both sides, otherwise it's not going to be equal anymore. So times 66 over 21. This is just going to be 1. You multiply something times reciprocal, 1. So you're going to be left with M is equal to, now 35 times 66 divided by 21. Well, 35 is the same thing as, 35 is 5 times 7, and 21 is 3 times 7. So you're multiplying by 7 up here, and here you have a 7 in the denominator. You're dividing by 7, so they're going to cancel out. So this is going to simplify to 5 times 66 over 3, and then we could simplify it even more, because 66 is the same thing as 3 times 22. 3 times 22. And so you have 3 in the numerator, you're multiplying by 3, and 3 in the denominator, dividing by 3, 3 divided by 3 is 1. So you're left with 5 times 22, which is 110. So it would take her m minutes to eat 5 hot dogs at the same pace. Now, when some of you might have tackled it, you might have had a different equation set up here. Instead of thinking of hot dogs per minute, you might have thought about minutes per hot dog. So in that situation, if you thought in terms of minutes per hot dog, you might have said, okay, look, it took Micah 66 minutes to eat 21 hot dogs, and it's going to take her n minutes to eat 35 hot dogs, and if it's the same pace, then these two rates are going to be equal. They have to be the same pace. And so then you can solve for n, and actually this one's easier to solve for n. You just multiply both sides by 35. Multiply both sides by 35, and you're left with, on the right-hand side, you're left with just an m. And on the left-hand side, same idea. You're taking 35 times 66 21st, which we already figured out is 110. So 110 is equal to n. So once again, multiple ways to tackle it, but it's important that we got the same answer. We're told
That'll be more fun and speaks in lesson.
a recipe
We're recording. Oh, cool.
A recipe for oatmeal cookies calls for 2 cups of flour for every 3 cups of oatmeal. How much flour is needed for a big batch of cookie that uses 9 cups of oatmeal? So let's think about what they're saying. They're saying 2 cups of flour. So 2 cups of flour. 2 cups of flour for every 3 cups of oatmeal. For every 3 cups of oatmeal. For every 3 cups of oatmeal. So for every 3
6, I guess,
of oatmeal. For every 3 cups of oatmeal. And so they're saying how much flour is needed for a big batch of cookies that uses 9 cups of oatmeal. So now we're going to a situation. Now we're going to go to a situation where we are using 9 cups of oatmeal. Right this way. 9 cups of oatmeal. And I'll show you a couple of different ways to think about it, and whatever works for you, that works. So first of all, the one way to think about it, so we're wondering, we're going to say, look, we know if we have 3 cups of oatmeal, we should use 2 cups of flour. But what we don't know is if we have 9 cups of oatmeal, how many cups of flour do we use? That's what they're asking us. But if we're going from 3 cups of oatmeal to 9 cups of oatmeal, how much more oatmeal are we using? Well, we're using 3 times more oatmeal, right? We're multiplying by 3. 3 cups of oatmeal and 9 cups of oatmeal, we're using 3 times the oatmeal. Well, if we want to use flour as the portion, we have to use 3 times the flour. We're also going to multiply the flour times 3. When we multiply the flour times 3, we're going to have to use 6 cups of flour. We're going to have to use 6 cups of question mark 6 cups of flour. Another way you can think about it, that answers your question. That's how much flour we need for a big batch of cookies that uses 9 cups of oatmeal. The other thing is you could set up a proportion. You could say 2 cups of flour over 3 cups of oatmeal. 3 cups of oatmeal is equal to question mark, and I'll say, instead of writing question mark, I'll put a variable there. I'll say is equal to a question, actually let me put a question mark here, just so you really understand. Is equal to a question mark in a box, number cups of flour, over 9 cups of oatmeal. 9 cups of oatmeal. And so, I like this first one, it's really just common sense. If we're tripling the oatmeal, then we're going to have to triple the flour to make the recipe in the same proportion. Another way, once you set up an equation like this, is actually to do a little bit of algebra. Some people might call it cross-multiplying, but cross-multiplying is still using a little bit of algebra. And I'll show you why they're really the same thing. In cross-multiplication, whenever you have a proportion set up like this, people will multiply the diagonals. So when you use cross-multiplication, you'll say that 2 times 9, so 2 times 9 must be equal to question mark times 3. Must be equal to question mark times 3. Must be equal to whatever's in this question mark, the number of cups of flour, times 3. Or we get 18 is equal to whatever our question mark was, times 3. So the number of cups of flours we need to use times 3 needs to be equal to 18. What times 3 is equal to 18? You might be thinking in your head. That is 6. Or you can divide it by 3 and you will get 6. So we get question mark in a box needs to be equal to 6 cups of flour. Same answer we got through kind of common sense. Now, you might be wondering, hey, this cross-multiplying doesn't make any intuitive sense. You know, why does that work? If I have something set up like this, proportion set up, why does it work that if I take the denominator here and multiply it by the numerator there, that needs to be equal to the numerator here times the denominator there? And that comes from straight-up algebra. And to do that, I'm just going to rewrite this part as x, just to simplify the writing a little bit. So we have 2 over 3 is equal to, instead of that question mark, I'll write x over 9. And in algebra, all you're saying is that this quantity over here is equal to this quantity over here. So if you do anything to what's on the left, if you want it to still be equal, the thing on the right still needs to be equal, you have to do the same thing to it. And what we want to do is we want to simplify this, so all we have on the right-hand side is an x. So what can we multiply this by so that we're just left with an x, so that we've solved for x? Well, if we multiply this times 9, the 9s are going to cancel out. So let's multiply the right by 9, but of course if we multiply the right by 9, we have to still multiply the left by 9. Otherwise, they still wouldn't be equal. If they were equal before being multiplied by 9, for them to still be equal, you have to multiply 9 times both sides. On the right-hand side, the 9s cancel out, so you're just left with an x. On the left-hand side, you have 9 times 2/3, or 9 over 1 times 2/3. Or, this is equal to 18 over 3. And we know that 18 over 3 is the same thing as 6. So these are all legitimate ways to do it. I want you to understand that what I'm doing right here is algebra. That's actually the reasoning why cross multiplication works. But for a really simple problem like this, you can really just use common sense. If you're increasing the cups of oatmeal by a factor of 3, then increase the cups of flour by a factor of 3.
Road trip.
Your car gets 25 miles per gallon. And you want to go on a 400-mile road trip. Right now, gas costs $3 per gallon. How much will the gas for your road trip cost? So let's see, they tell us they're going on a 400-mile road trip for 400 miles. So the first thing that I want to think about is, well, how many gallons am I using? Well, once I know how many gallons I'm using, I know it's $3 per gallon, so I can multiply the number of gallons by $3. So we figure out the number of gallons. But I want to multiply 400 miles, but I want to multiply that times the miles per gallon, which is 25, or would I want to multiply by the gallons per mile? If I multiply by the gallons per mile, then I would get, and multiply that times 400, then I would get the number of gallons. So let's just think about that. I want to multiply that times, the units first, the gallons per mile. The gallons per mile? And what are the gallons per mile? We have 25 miles per gallon. We have 25 miles for every 1 gallon, or you could say we have 1 gallon for every 25 miles. So I really just took the reciprocal of 25 miles per gallon and made 1 over 25 gallons per mile. Now what do we get when we multiply these two things? The whole purpose was to figure out how many gallons we're going to use. Well, we see that our miles cancel out with miles, and then I have 400 times 1 over 25 gallons, which is the same thing as 400 divided by 25 gallons. This is equal to 400 over 25 gallons, which is the same thing as 400 divided by 25 is equal to 16 gallons. Now, it's always important to do a reality check here, not just to try to blindly cancel out units. Does this actually make sense that 16 is a much lower number than 400? Well, sure it does. And actually, if you have an experience learning a car, you sense that, okay, well, that's about the size, on around 16 gallons. A car tends to go 300 to 400 miles if it gets pretty good fuel miles. That just makes sense from experience, and also makes sense based on how it's stated. You get 25 miles per gallon, so you're going to need fewer gallons than you're going to need miles. So this all seems to make sense so far. But we haven't answered your question. We want to know how much will my trip cost. Right now, we just figure out how much fuel we're going to use. So then we can take our 16 gallons, and to figure out the dollar cost, we're going to multiply by dollars per gallon or gallons per dollar. Well, if we're thinking just about unit conversion, we want to multiply times the dollars per gallon. So write like this. Write like dollars per gallon. I should just write out the word dollar. Dollars per gallon, the units will cancel out. It also makes sense. If I have a number of dollars per gallon, I multiply 10 to the number of gallons, and that's going to tell me how much it's going to cost. This happens at the fuel pump every day. Hey, $3 per gallon, we'll fill up 16 gallons. Hey, 3 times 16. So let's do that. So it's $3 per gallon. We see the gallons cancel out, and we are left with 16 times $3. 16 times $3, which is the same thing as $48. And
to 25 miles per gallon. Why did you write it by 1 over 25? I mean, I could write it like how this one stated, like 25 over 25 miles per gallon. Oh shit. So if you write it like that, then it would be 400 miles squared. That's insane.
Your car gets 5 liters. The whole purpose mile times. So I want to multiply times. All right, the units first. The gallons per mile. The gallons per mile. And what are the gallons per mile? We have 25 miles per gallon. We have 25 miles.
You wrote it like that so you can cancel shit out?
Or you could sure so far. By whatever number of dollars per gallon, I multiply 10 to the number of gallons, and that's going to get like this. Just about unit conversion, we want to multiply times the dollars per gallon. So write like this. Like dollars per gallon. You can just write out the word dollar. Dollars per gallon, the units will cancel out. It also makes sense. If I whatever number of dollars per gallon, I multiply it times the number of gallons, and that's going to tell me how much it's going to cost. It's up to every day. Hey, $3 per gallon. I'm going to fill up 16 gallons. Hey, 3 times 16. So let's do that. It's $3 per gallon, $8. And
Okay. Holy shit, I can do all of this now. Should I do it now? Oh my gosh, it's pretty hard. I don't even remember. Take me a while. I should do it in another video. Solve for K. Okay, so multiply the 90 divided by 3. Actually it's just 30, right? Oh my gosh, I could be wrong, but I'm sure it's 30. Okay, cool. I mean, multiply by 9, so multiply by 3 as well. I'm kind of using intuitive thing. Okay. So, I guess we could... I could reverse the same shit. We could do 9 over 10 equals Q over 3. Multiply both sides by 3. We get like 27 divided by 10. That's 2.7. Okay. Let's see. 8 times 5. 8 times 5. That's 40. Divided by 9. So we get 4. 36 and 4. 40. Whoa, holy shit. This is gonna be... No, this is insane. Let's try to do cross multiply this time. So we have 40 is equals to 9x and divide both sides by 9. What's this? Whoa, 36, and then we get 4, and then we get 36. 40 over 9. Let's just simplify the shit. Let's see, this is over 40 over 9. Really? Come on, man, so dumb. Solve for K. Oh, this looks like a trap. Okay, let's see. We can multiply. We can try 10 over 9 equals K 10 100 divided by 9. What's 100 divided by 9? Let's see. Let's see. 1 time 9, 10, and then 1 time. Just 100 divided by 9. Okay. So we have 18. So this is gonna be like 15 divided by 4. But let's check if that's actually true. So 15 equals 4k by 4. 44. Oh man, it's a lot of questions. Here folders scores 2.91. Which equation will determine the cost of 2 folders? Oh wow, 2.91? No. 3.21, okay, this one work. No. 10 books. 8 books cost. So we have 8 over 19.60.
No. No. Wait, what? No. Oh, this one. 10 books is 19. No, this one would work. Oh, same shit, just a word, not the above. Five would cost now. No. No. It should be, the rate should be like that. Oh, none of the above again? This is insane, bros. This isn't supposed to be like a cosmic plot. This is proportion bullshit. And you're dealing with the same units if it's gonna be forfeit, so it can be. Then hours times constant. 2 hours times. So we have 10. No. 10. No. 10. No. Okay, this one work. 10. Oh shit! It should be in this guy. Oh my god. Makes me want to kill myself. 9 pencils cost. Okay. That's fine. Being erased again. Just looking at the signs. Erasers cost. No. 6 or 4, no. No. Let's reverse the shit. make it easier, so we have 8. Oh, wow, we already solved for this one. It's 110, right? Oh my gosh, I hate myself so much. Okay. Wait, what? It's 7 times 5 and 7 times 3, so this one dies. And then 3. Oh fuck, it's 10. Okay. Sammy 6 loads up Alfred on 8. I can 8. Load up the ring stuff. Okay. Dito uses 9 liters of water to flour 40. What's this? 2440 divided by 4 times 6 and 4 10. Then we have 90. Let's just do this first. We can do 3 and 2. And then 15 liters. That's pretty sick. I like it. All the simplification stuff. Oh my god, how long have I been recording? Oh wow, cool. Yo, I'm stuck. Do I have internet? I do have internet. So why is this stuck? I don't know. Let's just try again. Let's see. Quessy is putting on sunscreen. Okay. He uses 3 ml to cover 45 Wow, okay. Same square of skin. Okay, cool. 240 over x plus 3 over 4, 5. So we have 240. Let's see. 9 1 not really. This is 9 times 5, and this is 5 times, let's see, what's this 5? This is 5 times 60. Where am I going to say 60? What the fuck? 5 times, yo, I don't know, what the fuck? 5, let's see, 4, 20, 48, wow, it's insane. Can I confirm that? 5x 40. For 20, 24. Okay, 6 halves 48. Let's do that. Let's do 40. 5 and 5, so 9 and 48. But we can do 1 over here and then 3, so we have 48 divided by 3. So what is that actually? I don't know. 18. 6. 6. 16. Dude. Oh yeah, pretty sick. I'm pretty sick. Okay. I'm gonna mass 4 again. What is the mass of the shorter part? Let's see again. So okay. Uh, 543x, so it's gonna 3 multiplier shit. So yeah, 120 divided by 5 is 20. I guess actually not. It shouldn't be 20 though. It's 24, man. It's 24. So we have 3 times 2, we have 6 R's. Okay, cool. Yeah. Recording. Yep. Okay, last one. Every day a group of 9 workers picks pods in a field. Each worker picks. What? Every day, a group of 9 workers picks pea pods in a field. Each worker picks 240 pea pods, and each pea pods contains 6 peas. How many peas do the workers pick every day? I'm supposed to say this times 9 times 6 is 54. Yo, that's insane amount of number. Donald sells 760 marbles every day. He sells each marble for $1.5. Oh wow. So let's see. Let's do it for 760. Times 140. So we can do 3, 4, 20. Should be about 3. Mauricio wants to fry 18 potatoes per hour for 2 hours. You can fry 6 potatoes using 1 liter of oil for frying potatoes. Okay, so he needs like for 3.5 hours, right? So you can fry 6 potatoes using 1 liter of oil. So this is already 3 oils. So we have 3 times 3, 5, so 10.5 liters. Guru Key watches 15 videos in Canada every day. Each video is 8 minutes long on average. For how many days you need to watch 9,000 minutes? Wow, it's an insane amount of videos. So each day he would be 8 times 15, 120. So 9,000 divided by 120, and be like 75 days. Cool. Oh, 75 days. Wow, that's insane. I mean, that's kind of the same rate for me. I watch about that amount of videos and more than that in a bit. How many days to finish? 75 days. How's the quiz? Man, I'm not sure. Oh, 5 questions. Please be easy. Okay, 3 answers. I think I've already solved this. Our proportions, right? So we can do 3.75 divided by 0.25. So 3 divided by 12, 5. 1.5 divided by 6, 5.75 0.25, of course, just to be sure. About 20, no. 3 points. Okay. The Go-Go uploads 2 videos from his channel every month. Each video gets an average of 1,500,000 new views. For how many months does the Go-Go need to upload videos to get on his channel? For how many months does the Go-Go need to upload? So every month we have 3 videos, right, for every month, and then each video gets, so we have 4 to 5 million. Let's just say 90. 1, 2, 3, 1, 2, 3 divided by 4. 1, 2, 3. 90 million versus No. It should be 20 marks, right? Why did you say 45 million? It's just 4 millions and, okay, let's see. 90, 1, 2, 3, 1, 2, 3, divided by 4 millions, right? 4.5, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, okay, we got 20. Rachel earned $34 in 4 hours. So shows how much you could earn tomorrow if you work for 10 hours at the same hourly rate. Okay, cool. So, you want to know how much you earn in 10 hours. And then, in 4 hours, you actually earn $34. So I can multiply this by 10. Get out. And then do that 2 times 2. And then 2 times 5. So we have 5 times. No, I don't cancel the shit out. And also we can cancel the shit out. So we get 34. 17, right? So 17 times 5 is gonna get us to 35, 35, 85. So that's your answer. You got 85. But of course, to be sure, this is a quiz. We should double check our answer. So in 10 hours and in 4 hours, right? So in 4 hours you earn 34, so how much are you gonna earn in 10 hours? So multiply by 10. So if you don't do the simplification, so we have 340 divided by 4. So let's just do that. 4, let's see, this is 8, so we have 32, and then we have 20, so 5, so 85. Wow, cool, okay. Yeah. At the beginning of the year, Adrian's service account was... no, it's not proportional. Terrell wants to drive his car at 150 miles per hour for... Oh, wow. Okay, it's hard. So, Terrell wants to drive his car at a speed of 50 miles per hour for 2.57 hours. Oh, I think this is just multiplication bullshit. Okay. Terrell wants to drive his car at a speed of 50 miles per hour for 2.75 hours. His car has a fuel efficiency of 25 miles per gallon. Wait, what? I'm a bit confused. Oh, 50 miles per hour. But this is per hour. 25 miles per gallon. I'm a bit confused. How many gallons of fuel will... Wait, what? Does it even need is 50 per hour? Okay, let's see. So 25 miles, 25 gallons, right? So let's see. So this. Two. That's so confusing. God, this is confusing. Oh man. Wow, that's a quiz. Oh, okay. I should stop here. I'm gonna do the unit test tomorrow. I'm just gonna pick up the equal. It's just 4 questions. That's insane. Okay, I'm just gonna look at the first question. I'm not gonna answer. Okay. So this is 1 to 8. Then this is the same shit. Yeah. This is for 8. It's B. But I'm not gonna do it now. Let's do it tomorrow. I'm gonna do it tomorrow. So for now, this is what I did. So we have 80% mastery for this section. From 7 to 3% to let's see, 77. Okay, cool. Whatever. Yeah. Let's see. I don't have money. I will give you money if I have. Wow, we're at 7 in. Wow. But I'm only at part 18. Feels like I've skipped stuff, but I need to catch up. The number of parts should be the number of streaks, so I would have to do like multiple parts in a day to be able to catch up. Yeah, okay, cool, bye. Gonna do the unit test, yeah, tomorrow.